Hi everyone, my name is Prashant Mohan Thakur, and I welcome you all in yet another topic today that we're going to study in our YouTube channel Competition Valley. Today we are going to study something that we have been very familiar with. It's HCF and LCM, very easy, very common, heard of topic. So we'll start directly with the concept. So HCF, we all know highest common factor. Now when we say highest common factor, what actually do we mean? So let's say we have to take HCF of, let's say we are taking HCF of 2 and 4. So what are we trying to do? What do we do at the back of our head is we take common factor of 1 and 2 and factors of 1, 2 and 4. We take factors of 2 and 4 and then we see what all are the common. So we see 1 and 2 are common, and in these two, 2 is highest. So we see 2 is our HCF. Similarly, if we say for, let's say, 6 and 8, okay, so again what we are doing, we're trying to find factors of 6 first. 1, 2, 3 and 6. Similarly 1, 2, 4 and 8. So what do we find? We find 1 and 2 to be common, and 2 would be our HCF. So what are we trying to do? We are just taking some numbers, we're trying to find the factors, and we're trying to see what all numbers are common, and this is true for all the numbers, and whatever is common we try to make them as the highest common factor. Now if we try to find HCF of 10 and 15, again it would be the same. We're trying to find for 10 first, so 1, 2, 5, 10, and for 15 it's 1, 3, 5, 10, 15. So what do we find? The highest common factors are, if we try to find, it is what are we getting in common? We are getting 1, 5 and 10. These are the things, but in 15 you don't get 10, so you're not getting 10 common in 15. So 1, 3, 5 over here, 1, 2, 5, 10 over here, so 5 is common, so we can say HCF is 5. Now this is how we have been doing all as our, when we were a student, when we were a child. Now we have to, it will be the same approach, but we need to find how we have been doing actually, what has been happening in the background. Okay, that's what we need to know. Okay, so let's say if you're finding HCF AB, okay, so what are we trying to do is we are just trying to do this. HCF of AB would be any factor of B minus A. Now let's take a proof. Okay, take HCF, let's say any number, you can say 20 and 30. So we said any factor of B minus A, so it should be any factor of 30 minus 20, which is 10. So if we take factors 1, 2, 5 and 10, so what do we see? We see that 10 divides both these numbers, therefore HCF is 10. Now this is true for all the any numbers you can take. You can take HCF of maybe, let's say 24, or you can say 32, 36, 39, 40, any number you can say. Now this is, again, this may look like this: A, B, C, D, E, or it may go on anyway. Even in such scenario we have to use the same concept, but in a little easy manner. So we need to look for those two numbers where we assume that the difference would be the least. Okay, so let's say if we find 32 and 36, we see that the difference would be 4. We can do it for 24 and 42 as well. The difference would be 18. Then we need to find factors for 18. That's little cumbersome and time taking, and in examination time is our main weapon. You just can't give it like this. Okay, so if we do this way, we see that 36, so what would be any factor of 36 minus 32, which is what? 4. So factors of 4 are 1, 2, 4. So we'll see that 4, I believe, or what? We'll see that 4 divides all but 39, 2 divides all but 39, 1. So what would be our HCF? Our HCF would be 1. Okay, now you could have taken any other number for difference. You can say you could have taken 24 and 42, so it would have been any factor of 42 minus 14. 42 minus 14 is what? It is 28. So what is 28? 1, 2, 4, 7, 14, 28. Now you will find that 28 does not divide all, 14 does not divide all, 7 does not divide all, 4 does not divide all, similar with 2. So again our HCF is 1. So you can go any way, but the answer would be the same. Okay. Okay, yeah. So this is what our answer is. Okay. Now we'll go ahead and we'll do some more numbers just to explain you this is a correct concept. Now what if we have to find, let's say find HCF of 108, 220, 230 and 390. So again, A, B, C, D format. So we need to do the same thing what we have been doing. We need to find the we need to pick those two numbers as A and B where we suspect or where we anticipate the difference to be minimum. So we see these two numbers look like the same. Again, you can do any way. The difference, it's not going to make any much difference. The answer would be the same, but still we can, just to save our time, we can do this HCF what? Any factor of B minus 8, so 230 minus 220. So it's any factor of 10. What is 10? 1, 2, 5 and 10. So we'll see. Let's see what should be the greatest one. So 10 does not divide 108, so it would not be. Again, same with 5. So HCF over here would be 2, because 2 would be a factor of all these numbers. Okay, so we're doing the same thing, nothing's exceptional. Okay, now we'll move on. So the next method is about co-prime. Now before we go ahead, we need to know what co-prime are. So let's say 4 and 9. If we ask you, if we talk about what are the things in common, so it's 1, 2 and 4, that's the factor, and 1, 3 and 9, this is 9's factor. So what is the common? Only 1 is common. So 4 and 9 are co-prime. It could be any other numbers. Let's say you could have 2 and 3 are in common, 2 and 5 are in common, 5 and 8 are in common, 5 and 8 are co-primes, 2 and 3 are co-primes, you can say 3 and 7 are co-primes. Doesn't necessarily has to be all odd, it could be anything. It could be 10 and 19 as to be co-prime. So in co-prime, the HCF is 1. When we say HCF is 1, it means that only common number is 1. So then it is co-prime. So we'll see how it works. So let's say we need to find HCF of, let's say 10 and 20. Okay, so how can we express this set of number in different ways? Okay, so this is one way we can do. Now this is 10 is common, and when 1 and 2 are co-prime to each other because they have nothing in common apart from number 1. Okay, so we can say 10 is our HCF. But some of you may say, okay, we could have written this way as well. Okay, well, you could have expressed this way, but then you cannot derive HCF from it because see, 2 and 4 are not co-prime. They have more than 1 in common. So this would be wrong. So HCF would be 10. Similarly, if I have to ask you, I can say 50 or 100 maybe. Again, what we can write 50 as, we can write 50 into 1 and 100 as 50 into 2, and we can claim that 50 is the HCF, isn't it? But again, some of you may say 50 we could have written 10 into 5, and 100 we can write 10 into 10. But again, 5 and 10 are not co-prime. Therefore, you cannot derive HCF from this process. Okay, we'll do just a small illustration. So let's say if I have to find HCF over here, so what we can do, we can write this as 19 into 2 into 19 into 3, and what we see HCF is 19, isn't it? Why? Simple, because this is highest, this is common, and this is co-prime. Very much simple. Okay, now we'll do another question. Find HCF of these two. So again, we have learned the method, B minus A method, the difference method, what we have studied at the beginning. So we can say HCF would be what? HCF would be any factor of B minus A. So it would be 10004 minus 10002. So what we get? Any factor of 2. So 2 factor is 1 and 2. So 2 could be the HCF. So 2 would be the HCF. Now, the purpose of me giving this question over here is because there's a concept hidden over here. Okay, so we'll just try to do that concept. The concept is HCF of, I would say the HCF of any two consecutive even number is always, it's always 2. Any two numbers you can say, it could have been HCF of 998 or 1000. These are two consecutive even numbers. So HCF any two consecutive even numbers would always be 2. So you can blindly write 2 away. You need not to pick up pen or need not to do anything. It could have been in this form as well. HCF of 2 to the power, let's say 2 to the power 6 and 2 to the power 7. Doesn't matter. It could have been in any HCF of 3 to the power 3 minus 1 and 3 to the power 3. It could have been plus 1. Still, it would be 2. Okay. It could be in any form, but you need to detect if it is two consecutive odd numbers or not. If it is, you can simply mark it as 2. Okay. Now we'll do another question. Okay. We need to find HCF of this. Again, we know the B minus A method, but this time we are not going to apply it because, as I say, time is our weapon. So what are we going to do? We are going to learn one more concept. The concept is, as we have studied earlier, HCF of any two consecutive odd numbers will always be 1. Any two number, again it could be in any format. It could be 2 cube plus 1 and 2 cube. Let's say it should have been minus 1 first, but I'm assuming B minus A format as well. Minus 1. So these two are what? These two are set of two consecutive odd numbers. So any two consecutive odd numbers, it will always be 1. So this is a concept. Okay, we'll do another one now. Okay, now this number looks very dreadful. That how are we going to do this? So understand this. Okay, and we'll do a couple of examples on this. So it says HCF of this and this. So simple HCF would be, see how many times 6 are we writing over here? So I'm just HCF would be 6 written 6 times and 9 times. So HCF would be 6 written and then HCF of 6 and 9. Okay, let me write it. HCF would be 6 written, yeah. So 6 written, HCF of 6 and 9. Now HCF of 6 and 9 is what? 3. Very simple. B minus A, any factor of 3. So any factor of 3 is 1, 2 and 3. So 3 would divide both. So 6 written 3 times. I'm just writing word by word so that even if you don't understand, you can just simply follow what's written there. So 6 written 3 times. 1, 2, 3. Now just see what has happened. Just look for a minute. Now we'll do another question over here now. Now find HCF. Again, the same thing, but what the same process. The process the process would not change at all. Okay. So what it would be? The HCF would be 6 written how many times? 4 and how many times? 3, 3, 3, 1. So 10 times. So 10 and 4 HCF is what? Any factor of 6. Any factor of 6 would be what? 1, 2. So it should be, yeah. Okay. If I take, so 6 written 2 times. So it will be 66. Okay. Now, if I take over here, let me just, I'll write one question and over here, just to ensure that I can make it a bit relative over here. This is what we have done. So just one question over here. So find HCF, and let's say 3. Okay, we can make it 3, and we can make it 5. So what would it would be 6 written 3 times and 5 times, isn't it? Now 3 and 5, we know what is that one thing is in common. HCF of 3 is 5 is what? 1, because there is nothing in common. They are co-prime to each other. So it will be 6 written once. So the answer would be this. Okay. It looks dreadful number, but it isn't. There's a method to do that. Okay. I will do some more question. Again, find HCF. So think for a moment before you do it. Just think, the number looks big. You cannot break it to this power. So whenever it looks difficult, it is very easy because there's certain concept hidden behind it. So what can we do simply? If we go simply from here, we see that these two are consecutive numbers, first of all. And second thing, what do we see? That this is what? This is an odd number. You can take 5, anything, 25, 125, any power on 5, 625. You can keep going. It would always be odd number. Okay. Any power on 5 would be odd. Any power on 3 would be odd. Any power on 7 would be odd. Okay. Because on odd numbers, it would always be odd. Odd multiplied by odd. Okay. So yeah. So the consecutive numbers. So this is odd. Odd minus 1 is what? Odd minus odd is what? See, 9 is an odd. 3, what do you get? Even. And in 9 minus 1 you can simply take, because let's assume, or let's assume 125 minus 1, what we get? Even. This is even. And this is what? Again, odd plus 1 is again even. Just think of, look over here, because 9 plus 1, any odd number you can take. 23 plus 1, any odd number it can be. 123 plus 1, 111 plus 1. What is this? These are two consecutive even numbers. What do we know? That HCF of two consecutive numbers, two consecutive even number is what? So that's the HCF. Okay. So what all we have studied today? We have studied about HCF, and we have studied how we can derive HCF. One is the old conventional method, wherein we used to take down the common factors, and then we used to take what is the common factor. And then what we have learned today, the same thing, but we have tried to break in form of factor of two numbers. If there are multiple numbers, we try to take two such numbers where we expect the difference to be minimum, so that once we factor them, we don't have to give so much of time, extra time. And then we have learned about the co-prime. This is what we learned. Okay. And then we learn how to derive these things what we have learned in finding HCF of some numbers, which looks like, let's say a, and then you have a. Okay, so how to find HCF? We learned this as well, that it will be a written, let's say 4 and 7 times, and then when we see in 4 and 7 times, the common would be only 1, so it will be only a. So we have studied it. In next class, in next video, we would have LCM, and we will see how we can derive LCM and how we can use this concept to do multiple questions, which would be very, very tough to look, but it will be very easy to derive. Okay, so please go through this video again and again, go through previous videos as well. If you have any queries, if you find any errors, any mistake, maybe even it's a calculation mistake, you can point it there, you can write it in the comment. There's nothing shame into that. Okay, I won't feel bad about that at all, because it has to be taken care of by me or by someone else, even if I've done something mistake. And revision is the key to success. You may have learned all the knowledge of the universe, but if you are unable to deliver it, it's just because of the revision. So please revise it as many as times. It's not about reading more, it's about revising more. Okay, so I hope you would have enjoyed the video, you would have learned something new. So I'll see you in next video. Till that time, you have a good day and all the best. Bye for now.